Hi guys, we're going to divide radicals today. So dividing radicals just means that you cannot have a radical in the denominator of your fraction, right? The top divided by the bottom. Just like we couldn't have imaginary numbers in the bottom, just like you can't divide by 0, you cannot divide by a radical. So how do you get rid of the radical on the bottom? You need to take the conjugate. Remember with imaginary numbers, if we had 3 plus 4i, the conjugate was 3 minus 4i. If we had negative 6 minus 2i, it was negative 6 plus 2i, to where only the sign in the middle changed. So the conjugate of radicals, if I had 3 plus the square root of 7, I would have 3 minus the square root of 7. If I had negative 8 minus 5 square roots of 2, then I would have negative 8 plus 5 square roots of 2. Only the sign in the middle changes. So whatever your conjugate is of the denominator, you need to multiply the top and the bottom by that conjugate. You multiply the top piece together, and then you multiply the bottom piece together. However, the bottom has this neat little shortcut. Remember, a squared minus b squared? So you don't actually have to do a lot of work to multiply the bottom together. So we'll start off easy, looking at the first example. 3 square root of 5 over the square root of 8. We can't have the square root of 8 on the bottom. So I'm going to multiply the top by the square root of 8 and the bottom by the square root of 8. I don't need to take the conjugate here because I'm not adding or subtracting anything to the square root of 8. So working straight across, if I look at the top, 3 square root of 5 times the square root of 8 gives me 3 square root of 40. 5 times 8 is 40. The square root of 8 times the square root of 8, 8 times 8 is 64. So then I look, can I simplify the top? 3 square root of 40. Well, what does 40 break down to? 8 times 5 is 40. 4 times 2 is 8. 4 is 2 times 2. So who gets to join the 3 on the outside? A group of 2. Who's left on the inside? 5 and 2. So my top becomes 3 times 2 is 6. 5 times 2 is 10. Well, what's the square root of 64, you guys? The square root of 64 is 8. And then you check. Outside, I have a fraction, 6 over 8. Can 6 over 8 be reduced? Sure. So 6 over 8 reduces to 3/4. So 3 over 4, square root of 10. Looking at B, I don't need to take the conjugate here. I have the square root of 15 over 5 square roots of 3. There's nothing added or subtracted to 5 square roots of 3. So how do I get rid of the square root of 3 on the bottom? I multiply the top and the bottom by the square root of 3. The square root of 15 times the square root of 3 becomes the square root of 45 on top. On the bottom, the square root of 3 times the square root of 3. 3 times 3 is 9. Can I simplify the square root of 45? Sure. 9 times 5 is 45. 9 is 3 times 3. So a group of 3 comes out. The 5 stays in. On the bottom, what's the square root of 9? 3. So 3 square root of 5 over, what's 5 times 3? 5 times 3 is 15. Can that, oh man, sorry guys. 3 square root of 5 over 15. Can that be reduced? 3 over 15 can be reduced to 1/5. So the square root of 5 over 5. If you feel the need to put the 1 in front, go ahead and do it. Alright, so those are the easy ones. Now we'll move up a level. Example 2 is where we actually need to start taking the conjugates. Why do we need the conjugates? Because I don't just have a square root on the denominator. I have the square root of 2 plus 3 on the first one. So what's the conjugate of the square root of 2 plus 3? Remember, you only change the second sign. So the square root of 2 plus 3 becomes the square root of 2 minus 3. Now looking at what's on top. On top I have a 5 times the square root of 2 minus 3. If I distribute, 5 times the square root of 2 is 5, square root of 2. 5 times negative 3 is negative 15. So putting that top answer back on top gives me that. Over the bottom piece. I gave you a shortcut for the bottom. It says take a squared minus b squared. If I do that, what are the two pieces on the denominator? I have a square root of 2 and I have a 3, right? So the square root of 2 squared. Well, what happens to a square and a square root? They cancel, and I'm left with 2. What's 3 squared? 9. What's 2 minus 9? Negative 7. So my final answer is 5 square root of 2 minus 15 all over negative 7. Okay? So you multiply the top and the bottom by the conjugate. You distribute on the top. On the bottom, you just do a squared minus b squared. All right, let's look at b. 4 square root of 5 over negative 3 minus the square root of 6. We have to take the conjugate here because I have two pieces on the bottom. So negative 3 minus the square root of 6, its conjugate is negative 3 plus the square root of 6. Okay? So now let's look at the top piece. On top, I have 4 square root of 5, and I need to multiply that with negative 3 plus the square root of 6. If I distribute, on the outside, I have negative 12 square root of 5. The next piece, 4 square root of 5 times the square root of 6 gives me 4 square roots of 30. 5 times 6 is 30. Okay, so if I put that answer back up top, I have negative 12 square root of 5 plus 4 square roots of 30 on top. On the bottom, I have a shortcut, a squared minus b squared. What are the two pieces on the bottom of my fraction? I have a negative 3 and I have a square root of 6. Well, negative 3 squared is 9 minus the square root of 6 squared cancels, and 9 minus 6 is 3. So I put that back on my problem. I have the top answer over the bottom answer, and I have my final answer. Okay? Now the last example is as hard as it's going to get. So, what do we do first? 4 plus the square root of 2 over negative 3 plus 5 square roots of 2. You multiply the top and the bottom by the conjugate of the bottom. So that means negative 3 plus 5 square roots of 2 becomes negative 3 minus 5 square roots of 2. And then I look at each piece individually. Up top, I have 4 plus the square root of 2 times negative 3 minus 5 square roots of 2. We need to go distribute this. This is what we learned on our last video. So 4 times negative 3 is negative 12. 4 times negative 5 square root of 2 is negative 20 square root of 2. The square root of 2 times negative 3 is negative 3 square roots of 2. The square root of 2 times negative 5 square roots of 2 is negative 5 square roots of 4. Okay? Now we combine our like terms. We have negative 12, negative 20 square roots of 2 minus 3 square roots of 2, combined to negative 23 square roots of 2. Remember, you add or subtract the coefficients together, you leave the radicals alone. Now the square root of 4 is 2, so that last piece becomes negative 5 times 2. So negative 12 minus 23 square roots of 2 minus 10. Negative 12 minus 10 is negative 22 minus 23 square roots of 2. Now that is only the answer to the top. Negative 22 minus 23 square roots of 2. Now we have to go to the bottom. So the bottom says a squared minus b squared. What are the two pieces we have on the bottom? We have a -3 and we have a 5 square roots of 2. So if I square that piece, I square that piece, and I subtract. -3 squared is 9, minus 5 square roots of 2 squared. Well, 5 squared is 25. The square root of 2 squared, remember that square root and the square cancel, so I'd have 25 times 2. So 9 minus 50 is -41. And I come back up here, I put that answer on the bottom, and now I'm finished. Top answer over bottom answer. All right, we have one more to try. 2 square root of 3 plus 2 square root of 5 all over the square root of 5 minus the square root of 3. What's our first step, you guys? Look at the bottom. I have two pieces. I need to take the conjugate of that. So the square root of 5 minus the square root of 3 becomes the square root of 5 plus square root of 3. Square root of 5 plus square root of 3. Now I'm going to go ahead and erase some of this work over here so we have a little bit more room. Okay? If I look at just my top piece, what is on top of this fraction? I have 2 square root of 3 plus 2 square root of 5 for my first parentheses, and I have the square root of 5 plus the square root of 3. We need to distribute here. So 2 square root of 3 times the square root of 5. Our first terms is 2 square root of 15. 3 times 5 is 15. So that's our first. Our outer, 2 square root of 3 times the square root of 3 is 2 square root of 9. 3 times 3 is 9. Our inners, 2 square root of 5 times the square root of 5 is 2 square roots of 25. And our last, 2 square root of 5 times the square root of 3 is 2 square roots of 15. All right, so now we need to see what can we combine. I have 2 square root of 15 here and 2 square root of 15 here. So 2 square roots of 15 plus another 2 square roots of 15 give me 4 square roots of 15. Well, what's the square root of 9? 3. So that piece becomes 2 times 3. What's the square root of 25? 5. So 4 square roots of 15. 2 times 3 is 6. 5 times 2 is 10. Putting our whole numbers together, 6 plus 10 is 16. And then I have 4 square roots of 15. So that's the answer to the top half of my problem. 16 plus 4 square roots of 15. All over the denominator. Well, we had a shortcut. A squared minus b squared. What are the two pieces we have on the bottom? The square root of 5 and the square root of 3. A squared minus b squared. A square and a square root cancel. A square and a square root cancel here. 5 minus 3 is 2. So putting that answer on the bottom gives me that. Now on this one, you might notice that all these numbers on the outside could be reduced. So if you can reduce them, I would. 16 divided by 2 is 8. 4 divided by 2 is 2 square roots of 15. If you don't reduce, it's not the end of the world. But this one would be the more correct answer. Okay? I know this was a lot, so just make sure you take your time. You multiply the numbers on the outside together of the radical, multiply the numbers underneath the radical together. Don't forget what a conjugate is, okay? And if you fast forwarded through this video, you lost all this work because I erased some of it. So please watch the video in its entirety, okay, you guys? I will see you in class. tomorrow.
Bye.